The massive cargo ship Atlantic Pioneer sat motionless in the middle of the Pacific Ocean, her engines silent for the third day in a row. Captain Rodriguez stood on the bridge, watching the sun set over the endless water, his face etched with worry lines that seemed to deepen with each passing hour. The ship carried $50 million worth of electronics bound for Japan, and every hour of delay cost the shipping company thousands of dollars. Below deck, the engine room had become a battlefield of frustration and failed attempts. The ship's chief, engineer Marcus Thompson, wiped sweat from his forehead as he stared at the massive diesel engine that had powered the vessel across countless ocean voyages. The engine, a behemoth weighing over 200 tons, had suddenly developed a mysterious problem that defied all conventional wisdom. The trouble began 3 days earlier, when the engine started making an unusual grinding noise, followed by violent vibrations that shook the entire ship. Thompson immediately ordered the engine shut down, fearing catastrophic damage. What he discovered when he opened the engine compartments left him baffled. All the obvious components seemed fine. The pistons moved smoothly, the fuel system functioned properly, and the electrical systems showed normal readings. Thompson had 30 years of marine engineering experience under his belt. He had fixed engines in storms, repaired systems in the middle of hurricanes, and solved problems that had stumped other engineers. But this particular issue seemed to mock his expertise. Every test he ran came back normal, yet the engine refused to run without those dangerous vibrations. The shipping company wasted no time in flying out their best troubleshooting team. Within 24 hours, 3 senior marine engineers arrived by helicopter, lowered onto the ship's deck with their expensive diagnostic equipment. Dr. Sarah Chen, the company's head of technical operations, led the team. She had a PhD in mechanical engineering and had solved some of the most complex engine problems in the industry. Dr. Chen's team immediately set up their sophisticated computer diagnostic systems, running cables throughout the engine room like electronic ivy. They connected sensors to every major component, monitoring pressure levels, temperature variations, and mechanical stress patterns. Their equipment could detect problems invisible to the human eye, measure vibrations down to microscopic levels, and analyze engine performance with scientific precision. For 2 full days, the expert team worked around the clock. They dismantled sections of the engine, examined each component under magnification, and ran computer simulations of various failure scenarios. They tested the fuel quality, checked the engine timing, and even brought in ultrasonic equipment to detect internal cracks that might not be visible. Dr. Chen was particularly puzzled by the engine's behavior. According to every measurement they took, the engine should run perfectly. All the mechanical tolerances were within specifications, the fuel system delivered proper pressure, and the electrical components functioned exactly as designed. Yet, whenever they attempted to start the engine, those violent vibrations would begin within seconds, forcing them to shut it down before serious damage occurred. The team tried everything they could think of. They replaced suspected components, adjusted timing mechanisms, and even brought in replacement parts flown in at enormous expense. Nothing worked. Each attempted solution ended the same way, with dangerous vibrations that threatened to tear the engine apart. As the days passed, tension on the ship grew thick as fog. The crew watched the experts work, hoping for a breakthrough that never came. Captain Rodriguez fielded increasingly urgent calls from the shipping company's executives, who were growing desperate about the mounting costs and delayed cargo delivery. The tour situation became even more pressing when weather reports showed a major storm system approaching their position. Being stranded with a dead engine in rough seas could turn an expensive problem into a dangerous emergency. The captain began making contingency plans for emergency evacuation, though abandoning a $200 million ship was an option nobody wanted to consider. Dr. Chen found herself questioning everything she knew about marine engines. She had solved problems on ships around the world, written technical papers on engine diagnostics, and trained other engineers in troubleshooting techniques. Her reputation was built on solving the unsolvable, yet this engine seemed to defy all logic. On the morning of the 6th day, with storm clouds gathering on the horizon, Dr. Chen made a call to her supervisor back at headquarters. She had never before admitted defeat on an engineering problem. But this situation was pushing her to that humbling moment. Her voice cracked slightly as she explained that despite having the best diagnostic equipment and most experienced team, they could not identify the root cause of the engine failure. The shipping company executives held an emergency meeting that afternoon. The costs were mounting exponentially, not just from the delayed cargo but from keeping the expert team on site, the helicopter transport costs, and the expense of replacement parts they had tried. More importantly, they were running out of time before the approaching storm system would make the situation truly dangerous. It was during this meeting that Admiral Harrison, a retired Navy officer who served on the company's advisory board, made an unexpected suggestion. He had been quietly listening to the technical discussions, his weathered hands folded calmly in his lap. When the executives finished expressing their frustration, the Admiral spoke up in his characteristic measured tone. The Admiral mentioned an old Navy colleague, a man named Frank Morrison, who had served as a chief petty officer in the engine rooms of destroyers and aircraft carriers for over 20 years. Morrison had retired from the Navy 15 years earlier, and now lived quietly in a small coastal town, working occasionally as a consultant on marine engine problems that stumped everyone else. Morrison was not a formally educated engineer like Dr. Chen's team. He had never earned advanced degrees or published technical papers. His knowledge came from decades of practical experience, from solving engine problems in the middle of combat situations where failure meant life or death. The Admiral explained that Morrison had an almost mystical understanding of how engines behaved, an intuitive grasp of mechanical systems that went beyond what any textbook could teach. The executives were skeptical. They had already invested heavily in bringing the most credentialed experts available, equipped with the most advanced diagnostic technology. The idea that a retired Navy mechanic could solve a problem that had stumped their PhD engineers seemed unlikely. However, with few options remaining and a storm approaching, they authorized the Admiral to contact Morrison and ask if he would be willing to help. Frank Morrison was tending to his small garden behind his modest coastal home when his phone rang. The 70-year-old veteran had weathered hands that showed decades of working with engines, and his calm gray eyes reflected the wisdom that comes from solving problems under pressure. He had been enjoying his retirement, taking on only occasional consulting jobs when something particularly interesting came along. Admiral Harrison's voice on the phone was urgent, but respectful. The two men had served together on the USS Enterprise years ago, and Morrison had always impressed the Admiral with his ability to diagnose engine problems that left other mechanics scratching their heads. The Admiral explained the situation with the stranded cargo ship, emphasizing that a team of highly credentialed engineers with advanced equipment had been unable to solve the problem. Morrison listened carefully, asking specific questions about the engine type, the symptoms, and what diagnostic steps had already been taken. His questions were different from what a typical engineer might ask. Instead of focusing on technical specifications, he wanted to know about the engine's history, when the problem first appeared, and what the ship had been doing in the days before the breakdown. After hearing the details, Morrison was quiet for a long moment. The Admiral could almost hear him thinking through the problem over the phone. Finally, Morrison agreed to help, but he made one unusual request. He wanted to speak directly with the ship's regular crew members, not just the expert troubleshooting team. He explained that the people who worked with the engine every day often noticed small changes that experts might overlook. Within 6 hours, Morrison was aboard a Coast Guard helicopter, flying toward the stranded ship. He carried only a small toolbox with basic instruments, no sophisticated diagnostic equipment, no computer systems, just simple tools that any mechanic might use. The contrast with Dr. Chen's high-tech setup couldn't have been more striking. When Morrison landed on the ship's deck, Captain Rodriguez greeted him with a mixture of hope and skepticism. The captain had been expecting someone younger, someone who looked more like the technical experts who had been working on the problem. Instead, he saw a gray-haired man in simple work clothes, who moved with the deliberate pace of someone who had learned not to rush into complex problems. Dr. Chen and her team were professional but clearly doubtful about this new arrival. They had already exhausted every sophisticated diagnostic technique they knew, and the idea that someone with basic tools could succeed where they had failed seemed to challenge everything they believed about modern engineering. However, they agreed to share all their findings and give Morrison access to their detailed measurements and test results. Morrison spent his first hour on the ship doing something unexpected. He ignored the engine completely. Instead, he walked around the ship talking to crew members about their daily routines. He spoke with the sailors who monitored the engine room during different shifts, the maintenance workers who performed regular upkeep, and even the cook who prepared meals near the engine compartment. His questions seemed almost random to the observers. He asked when crew members first noticed unusual sounds, whether anyone had felt different vibrations in their sleeping quarters, and if the ship had encountered any unusual weather or sea conditions in recent weeks. He wanted to know about minor maintenance work that had been done, changes in cargo loading procedures, and even modifications to other ship systems that might seem unrelated to the engine. The crew members found themselves opening up to Morrison in a way they hadn't with the formal engineering team. There was something about his calm, patient manner that invited confidence. Several sailors mentioned small details they hadn't thought important enough to report. Slight changes in engine sounds during certain weather conditions, minor vibrations they had noticed but dismissed in small maintenance tasks that had been performed weeks earlier. One particularly revealing conversation was with Jimmy Santos, a young crew member who worked in the engine room during night shifts. Jimmy mentioned that about 3 weeks earlier, he had noticed the engine seemed to run slightly differently during certain sea conditions. The difference was so subtle that he hadn't reported it, thinking it was just his imagination or fatigue from working long hours. Morrison asked Jimmy to describe exactly what he had observed, encouraging him to trust his instincts rather than worry about whether his observations seemed technically significant. Jimmy explained that when the ship encountered certain wave patterns, particularly long rolling swells, the engine seemed to develop a barely perceptible rhythm that wasn't normally present. This information interested Morrison greatly, though he didn't explain why to the others. He made notes in a small notebook, writing down details that seemed unimportant to the watching experts. His approach was methodical, but followed a logic that wasn't immediately apparent to the formally trained engineers observing him. After completing his interviews with the crew, Morrison finally entered the engine room, but instead of immediately examining the engine itself, he spent time studying the entire space. He looked at how the engine was mounted, examined the surrounding structure, and paid particular attention to connections between the engine and other ship systems. Dr. Chen's team watched with growing impatience as Morrison used simple tools to check things their sophisticated equipment had already measured with far greater precision. He tapped on metal surfaces with a small hammer, listening to the sounds they made. He felt various components with his hands, checking for temperature differences and vibrations that his fingers could detect. Morrison's examination of the engine itself was surprisingly brief compared to the days of intensive analysis the expert team had performed. He looked at the obvious components, ran his hands along various surfaces, and spent considerable time studying the engine mounting system. His focus seemed to be less on the engine's internal components and more on how it connected to the ship itself. After about 2 hours of examination, Morrison sat quietly in the engine room thinking. The expert team waited anxiously, wondering if this Navy veteran would prove to be another dead end in their frustrating search for answers. The storm clouds on the horizon were growing darker, and everyone could feel the pressure of running out of time. Finally, Morrison stood up and asked to speak with Captain Rodriguez and Dr. Chen privately. In the captain's quarters, he outlined a theory that surprised both of them. Morrison believed the problem might not be with the engine itself, but with how recent changes to the ship had affected the engine's relationship to the vessel's overall structure. His theory was based on the subtle observations from crew members. Combined with his examination of the engine mounting system, Morrison suspected that modifications made to other parts of the ship had created a resonance problem that only became apparent under specific conditions. The sophisticated diagnostic equipment had been looking for problems within the engine, but Morrison believed the real issue lay in the interaction between the engine and the ship's structure. Morrison's theory centered on something called mechanical resonance, a phenomenon that occurs when vibrations from one system amplify vibrations in another system at just the right frequency. He explained to Captain Rodriguez and Dr. Chen that ships were essentially giant floating structures that could develop harmonic vibrations under certain conditions, much like a tuning fork resonates when struck. The veteran mechanic had noticed something during his examination that the expert team's sophisticated equipment had missed. The engine mounting system showed signs of stress that weren't consistent with normal engine problems. The mounting bolts had minute metal filings around them, suggesting they were experiencing unusual forces. More importantly, some of the vibration, dampening materials between the engine and the ship's hull showed wear patterns that indicated abnormal movement. Dr. Chen was initially skeptical of Morrison's theory. Her team had measured vibrations throughout the engine compartment with sensitive equipment, and their readings hadn't indicated any unusual resonance patterns. However, Morrison explained that resonance problems often occurred only under specific operating conditions and might not show up in static tests or measurements taken while the engine was shut down. Morrison asked detailed questions about any recent modifications to the ship. Captain Rodriguez consulted his maintenance logs and discovered that 3 months earlier, the ship had undergone what seemed like minor modifications to improve fuel efficiency. The changes included adding new stabilizing equipment and modifying some of the hull plating to reduce drag through the water. These modifications had been tested extensively and approved by marine architects. They had successfully improved the ship's fuel consumption and had caused no apparent problems during several successful voyages. However, Morrison suspected that these changes might have altered the ship's natural vibration characteristics in subtle ways that only became problematic under certain conditions. The Navy veteran proposed a test that seemed almost too simple compared to the sophisticated diagnostics that had been attempted. He wanted to run the engine at very low power, while carefully monitoring not just the engine itself, but the vibrations throughout the ship's structure. His theory was that the resonance problem would build gradually as the engine speed increased, rather than appearing immediately at startup. Dr. Chen agreed to the test, though she remained doubtful. Her team had already tried running the engine at various power levels, and the dangerous vibrations had appeared within seconds every time. However, Morrison's approach would be different. Instead of monitoring engine performance, they would focus on measuring structural vibrations throughout the ship. Morrison positioned crew members at various points throughout the vessel, each equipped with simple contact microphones that could detect vibrations transmitted through the ship's structure. This low-tech approach contrasted sharply with Dr. Chen's sophisticated computer monitoring systems. But Morrison explained that sometimes the simplest tools provided the clearest information. The test began with the engine running at barely above idle speed. For the first few minutes, everything seemed normal. The engine ran smoothly, without the violent vibrations that had forced previous shutdowns. Dr. Chen's computer systems showed normal readings across all parameters, just as they had during previous tests. However, Morrison's human monitoring network began detecting subtle changes that the computer systems were missing. Crew members stationed throughout the ship reported barely perceptible vibrations that seemed to pulse in a slow rhythm. These vibrations weren't centered in the engine room. Instead, they seemed to travel through the ship's structure in wave-like patterns. As Morrison gradually increased the engine power, the structural vibrations became more pronounced. The crew members could feel the ship developing a subtle rhythm, as if the entire vessel was slowly flexing with each pulse. Morrison watched the engine speed carefully, noting exactly when these structural vibrations began to synchronize with the engine's rotation. At precisely 8:47 RPM, something dramatic happened. The subtle structural vibrations suddenly amplified, creating a feedback loop that caused the violent shaking that had been shutting down the engine. Morrison immediately reduced power, and the dangerous vibrations stopped. He had found the exact engine speed that triggered the resonance problem. Dr. Chen was amazed. Her sophisticated equipment had been focused on measuring engine performance, but had missed the critical interaction between the engine and the ship's structure. Morrison's simple approach had identified the precise conditions that caused the problem, something that had eluded days of high-tech diagnostics. Morrison explained that the recent hull modifications had changed the ship's natural frequency characteristics. The ship now had a resonance point that coincided with a normal engine operating speed. When the engine reached this critical RPM, it would trigger sympathetic vibrations throughout the ship's structure, creating a feedback loop that amplified until the vibrations became dangerous. The solution, Morrison proposed, would be to modify the engine's operating characteristics to avoid the problematic resonance frequency. This could be accomplished by adjusting the engine's fuel delivery system to change its power curve, ensuring that the engine would pass quickly through the dangerous RPM range rather than operating steadily at that speed. However, implementing this solution would require precise modifications to the fuel injection system, work that needed to be done carefully to avoid creating new problems. Morrison had the experience to make these adjustments, but it would mean taking apart systems that Dr. Chen's team had already examined and found to be functioning perfectly. Dr. Chen faced a difficult decision. Morrison's theory made sense, and his test had clearly demonstrated the resonance problem. But implementing his solution would require trusting his practical experience over the detailed technical analysis her team had performed. The approaching storm added urgency to the decision. They needed to get the engine running soon, or risk facing dangerous weather with no power. Captain Rodriguez was impressed by Morrison's systematic approach and clear explanation of the problem. The veteran's calm confidence contrasted with the frustration that had been building among the expert team. More importantly, Morrison had identified a specific, testable cause for the engine problems, while the other team had been unable to find any explanation for the mysterious vibrations. After consulting with the shipping company executives via satellite phone, Dr. Chen agreed to let Morrison proceed with his proposed solution. She insisted that her team monitor every step of the process with their diagnostic equipment, wanting to document exactly what Morrison did and how it affected the engine's performance. Morrison began working on the fuel injection system with the methodical patience of someone who had learned that rushing complex repairs often created more problems than it solved. He explained each step to Dr. Chen's team, sharing decades of practical knowledge about how engines behaved under different operating conditions. His work was precise despite using relatively simple tools, and his explanations revealed an intuitive understanding of engine dynamics that complemented the formal engineering knowledge of the expert team. Morrison worked through the night, his experienced hands moving with practiced precision through the complex fuel injection system. Unlike the expert team who had relied heavily on technical manuals and computer diagnostics, Morrison seemed to understand the engine through touch and sound. He would pause periodically to listen to subtle changes as he adjusted various components, his trained ear detecting differences that sophisticated instruments might miss. Dr. Chen and her team watched intently as Morrison modified the fuel delivery curves. His approach was methodical but intuitive, based on decades of experience with similar engines under various operating conditions. He explained that the goal was not just to avoid the problematic resonance frequency, but to do so in a way that maintained engine efficiency and reliability. The modifications Morrison made were relatively small but precisely targeted. He adjusted the timing of fuel injection at specific RPM ranges, creating a power delivery curve that would cause the engine to accelerate quickly through the dangerous 847 RPM resonance point rather than operating steadily at that speed. The changes were subtle enough that they wouldn't significantly impact overall engine performance, but specific enough to eliminate the structural vibration problem. As dawn broke over the Pacific, Morrison completed his modifications. The storm, clouds on the horizon, had grown darker and more threatening during the night, with weather reports indicating that the system would reach their position within 6 to 8 hours. The time pressure was becoming critical, but Morrison refused to rush the final calibration steps. Before attempting to restart the engine, Morrison conducted one more series of interviews with crew members who had worked in the engine room during the ship's previous successful voyages. He wanted to understand exactly how the engine had behaved before the recent problems began, gathering details about normal operating sounds, vibration patterns, and performance characteristics that the crew had considered routine. These conversations revealed additional information that supported Morrison's theory. Several crew members mentioned that the engine had begun sounding slightly different after the ship's hull modifications, but the changes had been so gradual and subtle that nobody had connected them to the recent catastrophic problems. The engine had been slowly developing resonance issues that finally reached a critical point during their current voyage. Morrison also discovered that the ship's loading procedures had changed slightly after the hull modifications. The new stabilizing equipment required cargo to be distributed differently to maintain proper balance. This changed loading pattern had subtly altered the ship's center of gravity and structural dynamics, contributing to the resonance problem that was now causing the engine failures. With this additional information, Morrison made final fine-tuning adjustments to his fuel system modifications. He explained to Captain Rodriguez that the engine should now operate normally, but recommended avoiding sustained operation at certain RPM ranges until they could return to port for more comprehensive modifications to the structural mounting system. The moment of truth arrived as Morrison prepared for the engine restart. Dr. Chen's diagnostic equipment was connected and recording every parameter, while crew members were positioned throughout the ship to monitor for any signs of the dangerous structural vibrations. Morrison's own monitoring system of human observers remained in place as a backup to the sophisticated electronic instruments. Morrison started the engine at idle speed, just as he had during his diagnostic test. The massive diesel engine came to life smoothly, running quietly without any signs of the violent vibrations that had been forcing shutdowns. Dr. Chen's instruments showed all normal readings, confirming that the engine's internal systems were functioning properly. Gradually, Morrison increased the engine speed, carefully watching for any signs of the resonance problems. The crew members stationed throughout the ship reported normal conditions as the engine speed climbed through the RPM ranges that had previously been safe. The critical test would come as they approached 847 RPM, the speed that had triggered the dangerous vibrations. As the engine reached 840 RPM, Morrison slowed the rate of acceleration, monitoring every system carefully. Dr. Chen watched her instruments intently, looking for any sign of the structural vibrations that had characterized the resonance problem. The crew members throughout the ship reported normal conditions, with no unusual vibrations detectable. The engine passed through 847 RPM smoothly, Morrison's modifications successfully preventing the resonance condition from developing. The fuel system changes caused the engine to accelerate quickly through the problematic speed range, never allowing the dangerous feedback loop to establish itself. Dr. Chen's instruments confirmed that structural vibrations remained within normal limits throughout the critical RPM range. Morrison continued increasing engine speed until they reached normal cruising power. The engine performed flawlessly, delivering full power without any signs of the problems that had stranded the ship. The deep, steady rumble of the massive diesel engine was music to everyone's ears after days of frustrated silence. Captain Rodriguez felt a wave of relief as he watched the engine performance indicators return to normal on the bridge displays. The ship was mobile again, and they would be able to maneuver away from the approaching storm system. More importantly, they could resume their voyage and deliver the valuable cargo that had been sitting motionless in the Pacific for over a week. Dr. Chen was professionally impressed by Morrison's solution, though she struggled to understand how he had succeeded where her sophisticated diagnostic approach had failed. Morrison explained that formal engineering training and practical experience were both valuable, but they approached problems differently. His decades of hands-on work had taught him to listen for subtle signs that instruments might miss, and to consider the entire system rather than focusing only on individual components. The expert team spent several hours documenting Morrison's modifications and testing various engine operating conditions to verify that the solution was stable and reliable. Their instruments confirmed that the resonance problem had been completely eliminated, and the engine would operate safely throughout its normal power range. Morrison also worked with Dr. Chen to develop recommendations for permanent modifications that should be made when the ship returned to port. While his fuel system adjustments had solved the immediate problem, more comprehensive changes to the engine mounting system would provide a long-term solution that wouldn't require the operating restrictions he had recommended. As the ship began moving again, cutting through the ocean swells toward their destination, Morrison prepared to leave. His work was complete, and the approaching Coast Guard helicopter would return him to shore before the storm system arrived. The contrast between his quiet departure and the dramatic arrival of Dr. Chen's expert team reflected the difference in their approaches. Morrison preferred to solve problems efficiently and move on, rather than seeking recognition for his accomplishments. Captain Rodriguez shook Morrison's hand warmly, expressing gratitude that went beyond mere professional appreciation. The veteran mechanic had not only solved a complex technical problem, but had done so under time pressure, and with the calm confidence that had prevented panic among the crew during a difficult situation. As Morrison packed his simple toolbox and prepared for helicopter extraction, Dr. Chen approached him with questions that went beyond the technical aspects of the engine repair. She wanted to understand how his diagnostic approach differed so fundamentally from the systematic methodology she had learned in engineering school and refined through years of professional practice. Morrison explained that formal engineering education provided essential theoretical knowledge and analytical tools, but practical experience taught different lessons about how complex systems actually behaved in real-world conditions. He had learned to trust observations that might seem insignificant to someone focused on technical specifications, and to consider interactions between systems that might not be obvious from individual component analysis. The conversation between Morrison and Dr. Chen revealed the complementary nature of their different approaches. Her sophisticated diagnostic equipment could measure parameters with precision that human senses couldn't match, while his experience-based intuition could identify patterns that instruments might miss. The ideal solution would combine both methodologies rather than relying exclusively on either approach. Dr. Chen realized that her team's failure hadn't been due to inadequate equipment or insufficient technical knowledge, but rather to their narrow focus on the engine itself, rather than its interaction with the ship as a complete system. Morrison's success came from his holistic understanding of marine vessels, developed through decades of working on ships where every system potentially affected every other system. The shipping company executives were fascinated by Morrison's unconventional problem-solving approach when Dr. Chen filed her detailed report about the incident. The report highlighted how Morrison had succeeded by gathering information that formal diagnostic procedures had overlooked, demonstrating the value of practical experience in solving complex technical problems. Morrison's success also raised questions about how the shipping industry approached maintenance and troubleshooting. Most companies relied heavily on formal engineering protocols and sophisticated diagnostic equipment, but this incident suggested that experienced technicians with practical knowledge might identify problems that escaped conventional analysis. The story of Morrison's successful diagnosis spread quickly through maritime industry networks. Marine engineers began discussing the case at professional conferences, analyzing how a Navy veteran with basic tools had solved a problem that had stumped a team of experts with advanced degrees and sophisticated equipment. Several shipping companies began reconsidering their technical staffing approaches, recognizing that practical experience and formal education both brought valuable perspectives to complex problem-solving. Some companies started recruiting experienced Navy veterans like Morrison to complement their existing engineering teams, creating a balance between theoretical knowledge and hands-on expertise. The incident also highlighted the importance of listening to observations from crew members who worked with equipment daily. Morrison's interviews with the ship's crew had provided crucial information that the expert team had overlooked, demonstrating that valuable diagnostic information often came from people who spent time with systems under normal operating conditions. Captain Rodriguez implemented new procedures on his ship based on lessons learned from the engine crisis. He established regular meetings where crew members could report observations about equipment behavior, even when those observations seemed minor or technically insignificant. This created a systematic way to gather the type of practical information that Morrison had found so valuable. The ship successfully completed its voyage to Japan, delivering the valuable electronics cargo only 1 week behind schedule. While the delay was costly, it was far less expensive than the alternatives that had been considered when the engine problem seemed unsolvable. The shipping company's insurance covered most of the extra costs, and the successful resolution enhanced their reputation for reliable service. Dr. Chen's team returned to their headquarters with new insights about diagnostic methodology that would influence their future approaches to complex technical problems. They began incorporating Morrison's systematic interview techniques into their standard procedures, recognizing that crew observations could provide information that instruments might miss. Morrison returned to his quiet coastal home and resumed tending his garden, characteristically modest about the achievement that had impressed the maritime industry. He continued taking occasional consulting jobs when particularly interesting problems arose, but he preferred the peaceful rhythm of retirement to the pressure of solving critical technical emergencies. Admiral Harrison was gratified that his recommendation had proved successful, but he wasn't surprised by Morrison's performance. The Admiral had observed Morrison's problem-solving abilities during their Navy service together, and he knew that practical experience often provided insights that formal analysis missed. The Admiral began recommending other retired Navy veterans for similar consulting opportunities. The broader maritime industry began developing new approaches to technical training that combined formal engineering education with practical experience. Some companies established mentorship programs pairing experienced veterans with younger engineers, creating opportunities for knowledge transfer that traditional training methods couldn't provide. Engineering schools started incorporating case studies like Morrison's engine diagnosis into their curricula, teaching students about the importance of holistic system thinking and the value of gathering information from operational personnel. The case became an example of how different types of knowledge could complement each other in solving complex problems. The success of Morrison's unconventional approach also influenced thinking about artificial intelligence and automated diagnostic systems. While sophisticated computer analysis had failed to identify the engine problem, Morrison's human intuition and experience-based reasoning had succeeded. This highlighted limitations of purely technological approaches to complex problem-solving. Maritime safety organizations began studying the incident as an example of effective crisis management under time pressure. Morrison's calm, methodical approach had prevented panic while systematically identifying and solving the technical problem. His performance became a case study in maintaining effective decision-making during high-stress situations. The Atlantic Pioneer continued operating successfully with Morrison's modifications, experiencing no recurrence of the resonance problems. The shipping company eventually implemented the permanent structural modifications that Morrison and Dr. Chen had recommended, creating a long-term solution that eliminated any operating restrictions. Other ships with similar hull modifications were quietly inspected for potential resonance problems, and several were found to have developing issues that were corrected before they became serious. Morrison's diagnostic approach was applied to these preventive inspections, identifying subtle warning signs that might have been missed by conventional analysis methods. 2 years after the Atlantic Pioneer incident, Morrison found himself receiving invitations to speak at maritime engineering conferences around the world. Initially reluctant to leave his peaceful retirement for public speaking, he eventually accepted several invitations after realizing that sharing his knowledge could help prevent similar crises for other ships and crews. Morrison's conference presentations were unlike typical technical lectures. Instead of focusing on theoretical concepts or sophisticated diagnostic equipment, he emphasized the importance of listening to equipment and understanding systems as integrated wholes rather than collections of individual components. His talks were filled with practical examples from his Navy career and civilian consulting work. Audiences at these conferences were fascinated by Morrison's stories of solving complex problems with simple tools and careful observation. Young engineers were particularly interested in his methods, recognizing that formal education had given them theoretical knowledge, but hadn't taught them how to develop the intuitive understanding that Morrison demonstrated. The maritime industry began establishing programs specifically designed to capture and transfer the practical knowledge that experienced veterans like Morrison possessed. These programs paired retired Navy engineers with younger professionals, creating mentorship relationships that bridged the gap between formal education and practical experience. Morrison's approach to problem-solving became known in industry circles as systems thinking, emphasizing the importance of understanding how different components interacted rather than analyzing them in isolation. This methodology was gradually incorporated into standard diagnostic procedures at major shipping companies. Dr. Chen had stayed in contact with Morrison, and their professional relationship evolved into a genuine friendship based on mutual respect. for their different but complementary approaches to engineering. She visited him occasionally at his coastal home, where they would discuss interesting technical problems while working in his garden. Dr. Chen eventually established a new department within her company focused on integrating practical experience with formal engineering analysis. She recruited several retired Navy veterans to work alongside traditionally trained engineers, creating teams that could approach complex problems from multiple perspectives simultaneously. The success of these integrated teams led to significant improvements in diagnostic accuracy and problem-solving efficiency. Complex issues that might have required weeks of conventional analysis could often be resolved in days when practical experience and formal methodology were combined effectively. Morrison's influence extended beyond the maritime industry as news of his unconventional success spread to other fields. Aerospace companies began recruiting experienced military technicians to complement their engineering teams, recognizing that practical knowledge could identify problems that sophisticated analysis might miss. Manufacturing industries also adopted similar approaches, establishing programs to capture the knowledge of retiring workers who had decades of hands-on experience with complex production systems. This knowledge transfer became particularly important as industries faced the retirement of experienced baby boom generation workers. The Atlantic Pioneer incident became a case study taught in business schools as an example of how different types of expertise could solve problems that seemed impossible when approached from only one perspective. The case highlighted the importance of intellectual humility and willingness to consider unconventional solutions when traditional approaches failed. Morrison continued his quiet consulting work, taking on perhaps 6 to 8 cases per year involving particularly challenging technical problems. His reputation grew through word-of-mouth recommendations from satisfied clients, though he never actively marketed his services or sought publicity for his achievements. Captain Rodriguez implemented the crew observation procedures he had developed after Morrison's visit, and these became standard practice throughout his shipping company's fleet. The procedures had identified and prevented several potential equipment problems before they became serious, saving the company significant costs and avoiding service disruptions. The Coast Guard began incorporating Morrison's diagnostic methodology into their marine safety inspection procedures. Inspectors were trained to interview crew members about equipment behavior and to look for subtle signs of developing problems that might not show up in standard technical inspections. Morrison's garden became an unlikely gathering place for some of the maritime industry's most respected professionals. Engineers, ship captains, and Coast Guard officials would visit him to discuss challenging technical problems, often finding that his peaceful environment encouraged the kind of reflective thinking that led to innovative solutions. The veteran's influence on diagnostic methodology extended far beyond the single-engine problem that had made him famous. His emphasis on holistic thinking and careful observation began changing how entire industries approached complex technical challenges. Universities started offering courses that combined traditional engineering analysis with practical problem-solving, techniques inspired by Morrison's methods. Admiral Harrison, now in his 80s, took pride in having recognized Morrison's unique talents and connected him with the Atlantic Pioneer crisis. The Admiral established a foundation that provided scholarships for Navy veterans pursuing civilian engineering careers, helping to bridge the gap between military technical experience and civilian industry needs. Morrison's story resonated particularly strongly with veterans transitioning from military to civilian careers. Many had extensive technical knowledge and practical experience, but felt overlooked by industries that prioritized formal educational credentials. Morrison's success demonstrated that military experience could provide valuable perspectives that complemented traditional engineering training. The shipping company that owned the Atlantic Pioneer experienced significant benefits from the lessons learned during Morrison's intervention. They established a technical advisory board that included both formally trained engineers and experienced veterans, creating a decision-making structure that could evaluate complex problems from multiple perspectives. Dr. Chen eventually earned promotion to Vice President of Technical Operations, largely based on her success in developing integrated diagnostic methodologies that combined sophisticated analysis with practical experience. She credited Morrison with teaching her that the most advanced equipment was only as good as the wisdom guiding its use. Morrison's approach to problem-solving influenced the development of new artificial intelligence systems designed to assist with technical diagnostics. Programmers realized that effective AI needed to incorporate the kind of holistic thinking and pattern recognition that Morrison demonstrated, not just mathematical analysis of individual data points. The broader implications of Morrison's success reached into fields far removed from marine engineering. Medical diagnosticians began studying his methods, recognizing similarities between complex engine problems and challenging medical cases that required looking beyond obvious symptoms to understand underlying systemic issues. As Morrison entered his mid-70s, he gradually reduced his consulting work, but continued mentoring younger engineers who sought his guidance. His modest coastal home became an informal academy where practical wisdom was passed from one generation to the next, ensuring that his unique approach to problem-solving would survive long after his retirement. The Atlantic Pioneer continued, operating successfully for many years, becoming something of a legend in maritime circles as the ship that had been saved by a Navy veteran with a toolbox and decades of experience. Captain Rodriguez kept a photograph of Morrison in his quarters, a reminder that sometimes the most sophisticated problems required the simplest solutions. Morrison's legacy ultimately transcended the specific technical problem he had solved. His success demonstrated the enduring value of practical experience, careful observation, and humble willingness to listen to insights from unexpected sources. In an age increasingly dominated by complex technology and specialized expertise, Morrison had shown that wisdom often came from understanding how all the pieces fit together rather than analyzing each piece in isolation. The veteran's quiet confidence and methodical approach to seemingly impossible problems inspired a new generation of engineers to value both formal training and practical experience. His story became a reminder that true expertise combined theoretical knowledge with the kind of intuitive understanding that could only be developed through years of hands-on experience with complex systems. Morrison continued tending his garden, satisfied that his knowledge had made a difference not just for one stranded ship, but for an entire industry that had rediscovered the value of listening to experience and thinking about problems as integrated wholes rather than collections of separate parts. His approach had proven that sometimes the most valuable solutions came not from the most advanced technology, but from the wisdom to understand how everything worked together.